Neil, maybe you could kind of take lead here since I'm a little bit spotty on my audio.
Okay.
I want to kind of give folks an update of our R&D session 2 weeks ago and then last week. We can use these slides if you want.
Yeah, so Randall was there in case I get anything wrong. We presented this slide in particular to show the different things where we had, for example, looked at Spark to use it as a, independently of GenevaERS, just with data. So we presented that. We presented Spark on ZOS with JSOS IO. And we said, well, we've had a go at this. We've made some progress, limited. Spark on ZOS with GenLib IO. And again, limited progress, but we have been learning, so it's been valuable to us. Sorry, which one of those was the Rocket software IO?
So this is the piece. If you look on ZOS, Spark calls, I didn't show it, Neil, to your point, MDS is an IO routine for Spark on ZOS.
Okay. So that's the first one. So we've tried just different mechanisms wherever they're from, wherever they exist. We've tried different things, and we've been learning as we go.
Mm-hmm.
Spark on ZOS with GenLib joins.
We didn't really go very far on that, did we, Neil? We just did JNI here.
Yeah, we didn't. And I guess we were the real reason for presenting these was to discuss the different approaches that we'd made and to ask for their ideas.
Right. This was kind of what we laid out a year ago as part of our R&D work, right? With Spark. So let me go, Neil, you've kind of talked through that already here.
Oh, sorry.
And we've presented this before. Let me just say briefly, we still think there's value for MR95 as the map phase against Spark as the reduce phase. So we think that there's potential value to be had in that space. Here's kind of where we've ended up in our last, a couple weeks ago, the day after we were presented as an OMP project. Should I go through this, Neil, or do you feel comfortable talking to this?
That's a slide that I've not seen more than once. So if you could go
Okay,
through.
let me just speak to it just briefly. As we talked about to Geneva today, right? Randall pointed out that we're already doing some work towards kind of a more Java flavor of GenevaERS. And Ian, you've been doing that based upon the logic table compiler conversion to Java. It isn't going necessarily from assembler, but it is getting us to a more consistent language. And if we were able to integrate more directly with Spark for MR88, we will have made progress towards more of a Java version of GenevaERS. The next step we could take, go ahead. Questions?
No, that's fine. We're getting there. I'm hoping to be able to get our demo views working through a Java MR91 in a few weeks.
Oh,
good. The thing that we could go to next is we could look at the MR95 startup task, the mother task, and evaluate if some of those pieces could be adequately performed in Java. This is not, this is more ideation, not a direction, but just an idea of where we could go. If we ever wanted to get to step 4, which would allow us to generate machine code on multiple platforms, we would kind of have to go through this step 3 first of converting the workbench to be more of a language. Because the workbench is really not multi-platform, it has been architected for multi-platform in the past, but that seems like a fairly complex maintenance approach. So if we went through a language as a separate interface, as another interface to GenevaERS, not doing away with the workbench, but as another way, that would set us up for multi-platform generated code.
you mean, for example, generating Java bytecode is one,
yes.
One avenue?
Yes. Thoughts, comments, criticisms, critiques?
That sounds great to me.
Well, you were part of building the slide, so I would hope so, Brandon.
Sounds like fun. I looked
you could
some.
Go ahead. Sorry.
So I looked at some time ago. I looked at very briefly at the whole business of what Java bytecode is, and I figure, at least in theory, we could create bytecode that looks a bit like our models. I don't know how in practice it would really work.
Yeah. Jill, I'm interested from the MR95, from the performance engine side. What does this make you think?
I'm afraid I just don't know anything about Java on the mainframe. Yeah, I can't really comment on how we do that. Ian seems to know a bit more than me. I need to do lots of research. I don't know. I think that, I'm not sure that we'd be able to create anything as efficient in assembler, but yeah.
I think we would give up efficiency, Jill. I think your assessment there is correct.
My impression is that we can do it, and it would be entirely portable and useful. But the value of IBM Z means that if we were executing on ZOS, we would still want assembler in some shape or form.
Yes, you would. So I agree with that, Neil, that you would still want the flagship performance, I think, would include the assembler machine code. We wouldn't think that the Java on Z would really give us a flagship sort of performance.
Yeah, it's a bit like DB2. DB2's, I know that's not open source, so it's another subject. But DB2 flagship is COS, but it exists in Linux, Unix, and Windows.
Yes. Jill, I think the thing that would be interesting to me for you to spend a few cycles, not, just maybe your pondering time. What if the mother task would be convertible to Java? And how much work would that be? Is there value in even considering this intermediate step here? Right?
Yeah, good question. I mean, I think at first we'd probably need to kind of write some kind of, just analyze and write some kind of pseudo logic to try and break down the chunks of, what it actually does. And then I think it'd be quite a big job to just even consider that. I don't know, well, maybe Neil agrees or disagrees, I don't know.
I think there's things we do that don't have to be in assembler. MR96, for example, and all the report writing stuff that happens after.
You say MR96, but MR96 builds the machine code. I mean...
Yeah, that's a one-time. I would separate what happens one time and what happens a billion times.
Yeah, sure.
Do the assembler in what happens a billion times.
I mean, are you really sure we can generate? I mean, are we gonna generate the machine code in assembler or in Java bytecode? I mean, I don't know anything about Java bytecode to know how we do that.
I think the idea here, Jill, just to answer your question, was that we would want to preserve the ability to do machine code, to have the flagship performance, but if somebody wanted to use GenevaERS multi-platformed, they could specify going to Java bytecode instead.
Okay.
Yeah, and I think that is something that is going to demonstrate ZOS as being the most performant platform. And if you don't need that much performance, then you can run it on your desktop or Linux machine.
Let me just reiterate that, Neil, going back to this slide. I think there's value in considering an MR95 kind of execution, even in a standard Spark setting. The way Spark works today, which has a very active community and lots of users, Spark's map phase really is limited to repartitioning the data based upon the available computing resources. So in that pass of the data that goes on in the map phase, Spark doesn't resolve any queries, doesn't do any special processing. It does one simple thing, repartitioning the data.
Which is not single pass. It's not single pass.
Which is not single pass. That's right. It always has two passes, a map phase and a reduce phase. For trivial kind of processes, MR95 in the map phase, if it could resolve all of the processes, even though the available computing resources might not be maximized, it may be still the most efficient. This would be on any platform. Okay. Let me go a little bit further. I think I'm giving you some thoughts, and it's good discussion. This isn't something, this is kind of thinking machine, what could be next sort of discussion, okay? I want to go a little bit further with what we talked about. We had Nicholas Marion joined our R&D session. He helped port Spark to ZOS, and he's joining again this week. Our last week's discussion, we kind of talked about potentially you could think of Spark streaming, where all of the threads, the multi-threaded processing under the mother task or a particular view, are streaming their data to Spark. We also noted that in a standard Sapper configuration or Geneva configuration, we have in the past had times where our views for multi-threaded views shared an extract file, and then you could run Spark against just the extract file. The downside to this configuration is that in the multi-threading mode, you're using NQDQ to share the extract files. A third approach, which is more efficient, is that each partition, each thread has its own extract partition, and we run MR88 against a concatenated set of extract files. We could consider Spark execution in that mode as well. Questions, comments? Okay, doesn't have to be.
Yeah,
okay.
Yeah, yeah. I guess we found in the past that to the extent that we can avoid having multiple threads writing to the same extract file, we can really save a lot of CPU time and elapsed time. It really is a burden on the system. Something we didn't know when we first started writing this years ago. We didn't think it would be a big deal to have multiple threads writing to the same extract file, but afterwards we found out, yeah, there's a big penalty for that.
Yep. And based upon your input, Randall, is why I drew this diagram on Friday. Our discussion this Friday is going to take this further. Go ahead, Randall.
I was going to say, by the way, I kind of forgot this piece a couple of weeks ago when I was putting the final touches on the demo. And originally, when Jeff and Sandy and Neil put the views together, they put all of the views pointing to one extract file. But then Michael took a look at that and thought, well, gee, shouldn't we split these things up to get more parallelism and not have the contention on the single extract file? And I thought, yeah, that's right, let's do that. But then I wanted to simplify the demo, so I put everything back into a single file so that I would have only one step in my JCL. And so then that's what I published then a couple of weeks ago. And then just today we were talking about it in our local US developer team meeting. And it occurred to me that, yeah, you know, I could have really left those as 3 separate extract files and just concatenated them together and still had one step. So that way I could have had the best of both worlds, good efficiency and reduced number of steps. So I want to change it back. I want to change it to do that. So I started doing some testing there. I'm having a little bit of problems. So as soon as this meeting's over, I want to show Ian something odd that I found when I tried changing back to having 3 extract files. I'm already one issue. So just FYI, that's where I'm headed.
Thanks, Randall.
Mm-hmm.
Okay. I'm not going to take a lot of time, but we're talking about the Spark integration R&D work is talking about streaming. MDS, the Spark IO module on the mainframe data services, uses JDBC, which basically is a hypersocket integration to feed data to Spark. there was a question of how to tell Spark not to do a map phase. Is there partition control parameters? And how can Spark use access the extract files? These are all kind of questions that have come out of our discussion about trying to integrate more directly with Spark in this process right here. Okay.
And they did think there might be a way to do that, to tell it, we've already partitioned into 3 partitions on the output. Can you put that back together for us after you processed it?
Yeah.
They thought there might be a way to do that.
Let me add, Neil, as an update that I gave you briefly today, and as an update to the rest of the team. Randall and I also had the idea late last week that we may be able to make progress thinking about the sort utility. The sort utility as something that could go with an MR95 integration process that would give us some of the characteristics of Spark, but might be faster for us to get there. So we're looking at inviting some members that work with sort utilities to join the project and have us and work together maybe on that as well. Okay.
This may be a dumb question, but doesn't Spark decide how to partition the files?
It does, Sandy, you're right. It uses parameters you give it for the available hardware, and it partitions based upon the parameters of the available hardware.
Mm-hmm.
That's why our question would be, can we override that? Because our MR95 would be assuming that the partitioning is already set. Okay?
Correct. But, you know, I guess the caveat there is that you know what the partitioning should be to be efficient, yes. Right? And so, you know, I think there's a piece there where we're kind of making an assumption that, you know, Spark will automatically tell them based on what they're trying to do what the correct partitioning is and automatically does it. Geneva doesn't do that.
That's right, Sandy. But let me make sure we're clear on the terminology, right? Spark is reducing the elapsed time by making 2 passes of the data. GenevaERS with Spark may be more efficient because 1 pass might be acceptable. It may not reduce wall time, but it will be more efficient if you only make 1 pass of the data.
Right, but you still have to tell it how to partition efficiently.
That's right. Yeah, that's right.
So it's not as smart as Spark.
No, you are right, Sandy.
I see an enhancement coming, Geneva.
Well, you're right, Sandy. That could be an enhancement that comes in at some point. Yes. And that's where this could go, right? Is in that same space. Just as a side comment, if you haven't signed up, you can go sign up on Apache Spark, on the Apache Spark website to be part of the email list. I get emails every day on questions about Apache Spark. It's a very active community. And you can just listen in. Just subscribe. You can pick the emails that are interesting to you. You can see what kinds of things are going on in the Spark world by doing that.